All right, picking up where we left off on number 21, we've got that same region of y equals x squared in the first quadrant, about y equals 4, about the line. Actually, this one doesn't say first quadrant, does it? So I'm beginning to think that this one's not the first quadrant. So I think it's the entire y equals x squared and the line y equals 4. And if I reflect that above the line y equals 4, do you see I have a disk method? Because this is my axis of revolution. So what I just need is my single r value, which is the distance from my outer part of the region to my line y equals 4. And to get that, get my r value, I need top curve minus bottom curve. So I'm integrating here pi times big R all squared dx, and then my limits of integration are going to be from here to here on the x-axis. And if y is 4, that means my first x value is -2, the other one is 2. And I'm going to show you that I will use symmetry here to double the region, but integrate it from 0 to 2, which is going to make my life easier in terms of my evaluating my antiderivative. So before I integrate, I need to actually FOIL this out to get 16 minus 8x squared plus x to the 4th dx. And I go from there. Integrate to 16x minus 8 thirds x cubed plus x to the 5th over 5, all from 0 to 2. So I have 2 pi times 32 minus, when I plug in 2, I get -64 thirds, so minus 64 thirds, plus 32 over 5. And then I've got to do some work to figure out what that is. And I'm going to be honest, I'm going to let you guys finish that, and you can do the algebra right now, because if I do it in my head, I'll probably make a mistake. So now I'm going to take, let's see, this guy and add in a new sheet, copy it in, and let's look at number 23. We have here the arch of sine x and arch of sine x, and here's one arch from 0 to pi. This is our region. We are reflecting it over the x-axis, and our mirror reflection looks like this. Here's how we're spinning it. So our r value is just sine. So sine of x squared, we're integrating that from 0 to pi, and we have pi r squared. So now you might want to know how to integrate sine squared of x by hand, but I'm going to be honest with you, we're not going to. The only way you could do it is if you go look up the sine half angle formula, which I do not expect you to memorize, and neither does the College Board. So frankly, this one would end up being a calculator integration problem. And I'll just leave it at that, and you guys can do that on your calculator. So let's go on to number 24. And this is, it's a trapezoid. So let's graph the trap. 2, 0, 2, 2, 4, 0, and 4, 4. So right there. And we're going to take this and we're going to spin it around the x-axis. Like that. It's going to spin for us. And actually what you have to do is figure out the equation of this line. So this is a line with a slope of 1 because I went from 2, 2 to 4, 4. So my slope is 1 and one of my points is 2, 2. So in point slope form, I have 1 times x minus 2 in paren plus 2. So that is y equals x. So x is our r value. So I have pi times the integral from 2 to 4 of x squared dx. That integrates to pi times x cubed over 3 from 2 to 4, which when I evaluate that, I get pi times 64 over 3 minus 8 over 3, which is 56 pi over 3. My answer is choice A.